Hello everyone, good morning. Am I audible?
Yes, sir.
Yes, sir.
Thank you. Good morning to all. Okay, let's wait for 1 minute so everyone can join and then we'll start the session. Uh, in the last lecture, we had completed the unit number 2, the uh, concept of logic and predicate theory, propositional logic and propositional predicate. That we had completed, and today I upload its PDF file, okay, in your login ID, so you can refer this unit and practice it each and every topic again, okay, and for any doubt, any query in this unit, you can ask me, okay. Today I upload this PDF file, okay, of unit number 2 in your e-content, so you can refer this PDF file, okay, practice each and every topic again by yourself, and if you have any query in any topic, we'll discuss it again. So today we'll start unit number 3. It is the relation and partial ordering theory. And in this topic, we'll identify some special type of relations for the set theory. Okay. And in this starting, there is some theoretical part there. So first, we'll discuss its theoretical data, how we can define relation, its properties, its conditions. Okay. And then after, we'll discuss its various type of example related to the relation. Okay. And the second part is there a partial ordering theory. It is part of the relation that, okay, we can define the partial order for any relation and its some various properties. Okay. So let's start this unit number 3. Okay. And from Monday, I think your offline classes will start. Okay. So we'll discuss uh, so unit number 3, that is the relations and partial ordering. And which topic we'll discuss in this unit? These are the topics which we'll discuss in this unit. The first part, okay, that is the relation theory. Okay, that is the part 1 that we'll discuss. And then after in part 2, we'll identify the partial ordering based on this relation theory. How we can define poset, totally ordered set. Okay, poset means partially ordered set that we'll discuss in this. And then after totally ordered set chain, it is also known as the chain. Okay, then after partially ordered relations, the order set, S diagram, list and greatest number, minimal maximum number. Okay, lattice theory, Boolean lattices. So that we'll discuss in this part 2. But now today we'll start this concept of relation, and in this first we'll identify, okay, we'll define the relation, how we can define it, its various type, okay, domain, then after range of the relation, universal relations, void relations, okay, and then after it types of the relations, that is reflexive, symmetric type, anti-symmetric, transitive, and so on, okay. And then after we can convert this relation data to the matrix form, okay, so that we'll discuss in this. We just connect this both point, both concept, okay, how we can convert any relation to the matrix form, matrix to the relation, okay. And then after it graphical view, okay, graph of the relations. And after that we'll discuss the partitions and covering of the set, okay. So that topic will discuss equivalence relations based on these types of the relations: reflexive, symmetric, transitive, and anti-symmetric. And then we can define equivalence relation, okay. Then after complementary block, composite relations, converse of the relations, transitive, and so on. Okay, so this various topics related to this concept. So that we'll discuss in the unit number 3. Okay, and in this GPU exam, that is the weightage of this unit is a 16 to 18 mark. Okay, weightage of this unit, that is a 16 to 18 mark will be there. Okay, in this GPU final exam. okay, in this final exam. Out of 70, 16 to 80 mark, okay, will covered from this unit. So it is important unit and it is simple, okay. It's very easy to uh, define it, any topics, okay, any definitions and any example. It's very easy to solve it, okay. We just apply some special conditions that to predict the answer, okay. So that will discuss in this uh, unit, okay. So now let's start the first topic, the definition of relation, okay. So how we can define the relation, okay, what is meaning of that? So the word relation, okay, it is a definition. And now in this lecture, okay, I will write each and every theory related to this topic by using this way, okay. You can keep the screenshot of this slide, otherwise you can prepare your book with this data, okay. You can continue this each and every topic, write down each and every topic in your lecture book. Otherwise you can take this screenshot, okay. This for your reference which topic we had completed in this last lecture and so on, okay. एंड आपके पास कोई रिकॉर्ड होगा कि कौन से टॉपिक हमने पढ़ लिए, ठीक है. सो कीप take this screenshot after completion of each and every topic in this slide, okay. Otherwise you can write down the each and every topic in your book, okay. That is depends on you. So what is meaning of relation? So word relation, okay, the word relation is used to indicate the relationship between the two objects, okay. That is the simple definition of relation between the two object. कोई भी object हो सकता है, ठीक है. And now you have to identify, you have to use the word relation. So it is used to indicate the relationship between the two objects. Object may be anyone that, okay. There are many kind of relationship in the world, okay. Object may be anyone that you can consider any two object to consider it relations, okay. So there are many kind of relationship in this world, okay. You can consider any two objects to indicate it relations, okay. But here in this topic, we'll discuss the mathematical definitions of the relations. Okay, so relations is often described verbally and it may be denoted by name or symbol and so on. Okay, so it is described. It is described verbally. Okay, and it may be denoted by. Okay, it is denoted by. It is denoted by name, otherwise any symbol, okay, name or a symbol. So that is meaning of relation, and it is defined in term of order pair, okay. It is defined, it is defined in terms of order pair. So this is the introductions of relations, okay. That is one theoretical point of view here. The word relation is used to indicate relations between two objects, okay. So there are many kinds of relations in this world, and it is described verbally, and it is denoted by a name or a symbol. It is the word, okay. That is not word. That is a word, and it is defined in terms of order pair. You can consider as a order pair to define the relation, okay. So now let us define the definition of relations on any set, okay. The definition of relations on set. Relations on a set, okay. So let us consider any two set. Let A and B are a two set. Okay, any two set you can consider, any two objects you can consider in this two set, and a relations from A to B. Okay, from A to B is a subset of the Cartesian product A cross B. Product A cross B. Okay, so how we can define Cartesian product, and then after we consider it any subset of A cross B, and this is called the relations from A to B. Okay, if we consider it counter example as a, let us take A is equal to 1 2. Okay, the two elements are involved in this A, and let us take B is equal to 3 4. Okay, there is a two element are in this B. Okay, and now first we'll define the Cartesian product. Okay, and then after we'll consider any of its subset, and that is called the relations from A to B. Okay, so how we can define A cross B? So A cross B, that is equal to AB. Okay, the order pair of the AB where A belongs to A and a B belongs to B. Okay, that is the definition of Cartesian product A cross B, that is equal to AB, or you have to include in the set all its order pair. Okay, where A belongs to A and B belongs to B. So here it is for AB. Okay, that is A is equal to 1 2 and B is equal to 3 4. So it will be A cross B, that will be, we have to collect all its order pairs. So let us consider first element here from this A, and we'll consider it pair with 3 and 4. So it will be 1 comma 3 and 1 comma 4. Okay, that is the first case. And now change the element, that is, let us take 2 here and make it pair with 3 and 4. Okay, the all element of the B. So it is a 2 3 and 2 4. 2 3 and the 3 2 4. That is the A cross B. Okay, it is called the Cartesian product A cross B. Clear? And now we have to consider if any of its subset. Okay, so let us consider its subset. Let us take its subset. Let us say it is R1. So R1 is equal to here. That is the arbitrary element I have considered. Okay, from this A cross B. Let us take 1 3 and a 2 3. Okay, so two entry I have considered from this A cross B. So now we can say if it is a subset of A cross B. Okay, A and B are the two set. Here I consider 1 2 and 3 4, and a relations from A to B is a subset of the Cartesian product. Okay, so now we can say R1 is a subset of A cross B. Okay, R1 is a subset of this Cartesian product. So we can consider R1 is the relations of A to B. R1 is the relations from A to B. You can also consider R2, that is equal to the, let us take a 1 4. Okay, and 2 4. That is also one subset of A cross B. So we can consider R2 is also the relations of A cross B. Okay, R2 is relations from also the A to B. Okay, these both are the relations example. And if we consider R3 as a, R3 is equal to, if I consider a 2 3 and a 5 6. Okay, two entry I have considered. Let's add one more one. Okay, that is 2 4. Let us take. Clear? So three entry I have considered from this A cross B. Okay, but now check this R3. So 5 6, it is not a part of A cross B. Okay, the entry 5 6, it is not a part of A cross B. So here we cannot say R3 is a subset of A cross B. Okay, here we cannot define, we cannot say R3 is also the subset of A cross B. So therefore R3 is not a relation. Okay, why it is not relations? Because 5 6, it is does not belongs to A cross B. Okay, 5 6, the entry, that is does not belongs to A cross B. Here R1 and R2 are the relations example. Okay, why it is relations? Because it is a subset of a Cartesian product. Okay, so this way we can define the relations for any two set. Okay, A and B are the two any set, and it may be any one object you can consider. Okay, and then after find out the Cartesian product of these two sets, and then after collect it any one its subset. Okay, if I include only one entry from this A cross B, it is let us take 1 and 3. So 1 and 3 is also called the relation. Okay, I have include only one entry from this set, so 1 3 is also known as a relation. Clear? So this is the definition of relations for any two set. Okay, and it is simple one. First we'll consider any two set, then after find A cross B. A cross B means the order pair, okay, of A and B. And then after consider it any of subset, okay, from this A cross B. So it is the relations, and if it is not a part of A cross B, then it is not a relation. Okay, and now it notations form. Okay, suppose R is any relations. Okay, suppose R is a relation from A to B, A to B, and then R is a set of order pair. R is a set of order pair AB. Okay, it is the relations AB where A belongs to A and B belongs to B. Okay, if suppose R is the relation from A to B, then R is a set of order pair. Okay, it is include the set of order pair. Here it is a 1 3, so it is a set of order pair. Okay, where 1 belongs to A and 3 belongs to B. Okay, here it is a 1 3 and 2 3, so 1 belongs to A and 3 belongs to B. Here it is a 2 3, so 2 belongs to A and 3 belongs to B. So it is one types of order pair. Okay, of the element of A and B, and every such order pair is written as a, okay, every such order pair, every such order pair, how we can written this? Okay, so it written as, it can be write as ARB, ARB. Okay, if AB belongs to R, if this order pair belongs to R, then how we can define the another way? That is known as a ARB, and it is read as A related to B. Okay, A is related to the B. That is the notations to define the relations. Okay, here it is AB belongs to R. Okay, this order pair are included in the relation. Okay, and it is a subset of the Cartan product also. So AB belongs to R. So how we can define another way? Here it is A comma B are in this relation. Okay, otherwise you can consider R is equal to the A comma B. Clear? Means AB belongs to R. We can consider AB belongs to R means A R B. Okay, A related to the B. Otherwise, you can also consider A is AB belongs to R. Otherwise, A related to the B. Okay, and if AB does not belongs to R, okay, if it is not belongs to R, A comma B does not belongs to R, it means A is not related to the B. Okay, A is not related to the B, not related to the B, and it is written as, it can be write as A not related to the B. Okay, let's consider one not related form. Okay, so here in this example, 1 3 belongs to R. Okay, 1 3 it is belongs to R1, so we can consider this is a 1 R a 3. Okay, it is a 2 3 belongs to R, so we can say 2 R3. Clear? Here it is a 1 4 belongs to R, so we can say 1 R4. Clear? It is a 2 4 belongs to R, so we can say 2 R4. But right now it is a 5 6, not the part of A cross. It means it is not a relation. 5 6 is not a relation. So we'll say that 5 R does not related to the 6. Okay, and you can use this notations for this. 5 does not related to this. Okay, so that is a meaning of this relation. And next is that R is called binary relation. So definition of binary relation. Binary relation. So R is called a binary relation. Binary relation from A to B. A to B, since element of set R are order pair. So R is called the binary relations from A to V. Okay? If since the element of the set R are a order pair. Okay, so that is called a binary relations definitions. And now let us consider one or two example related to this one, and we'll take the Cartesian product first, and then after we'll identify some relations. Okay, so one example, if A is equal to 1 to 5, okay, 3 entry are included, and B is equal to 2 and 4. Okay, so then find the first one, that is A cross B. Okay, means the Cartesian product of A and B, and then after second one, that is the R. Okay, as a x less than y. R as a x less than y. Okay, we will consider such relations R which follow this condition. Okay, first entry is a x, second entry is a y, and if it is follow this condition, so this entry will include in the relation. Okay, so let us first check the A cross B. So A is equal to 1 to 5, B is equal to 2, 4 is given here. So A cross B, that is equal to the let us consider the first entry from this A, and we'll make it paired to the both entry of the B. Okay, so 1 2 and then after 1 4. Okay, now change the element, that is let's take 2 and make it pair with all element of the B. So 2 comma 2 and 2 comma 4. Okay, and now change the element 3. It is a 5 here, so 2 comma 2, 5 comma 2 and 5 comma 4. Okay, how many pair you can define in the A cross B? That depends on the number of elements which are mentioned in this A and B. Okay, here it is the 3 entry are given in this A and B. Okay, 3 entry are given in this A and 2 entry are given in the B. Okay, 2 element. Here it is a 3 element. So 3 into 2, that will be the 6. 3 into 2, that will be 6. 6 pair you can define in the A cross B. Okay, 6 pair you can define the A cross B. If it is a 3 element are given in this B, then you can define the 9 pair. Okay, 9 various pair in this A cross B. Clear? So here it is the 6 pair that as per this okay data 1 2 1 4 2 2 2 4 5 2 and 5. Okay, and then after we'll check the solutions of second one. Okay, that is answer of first one, and now the second one. Okay, here we'll define the R. Clear? Such a way that if it is satisfy this condition, okay, the two element, first entry as a x, second entry as a y. Okay, we'll consider x from the A, x belongs to the A, and y belongs to the B. Okay, such that x less than y. Okay, so this pair will include in this relation. Okay, and which is also the subset of A cross a B. Okay, it should be also the subset of A cross B. So first pair will be the 1 comma 2. Okay, because why it is 1 comma 2, x is a 1, y is a 2, so it is satisfy this condition x less than y. Clear? So 1 comma 2 pair you can include, then after 1 comma 4 you can include. Okay, that is also satisfied. Now here we cannot include 2 comma 2. Why? Because 2 less than 2, it is not a true. Clear? So we cannot include the 2 comma 2 pair in this set. Okay, in this relation. Then after we can include 2 comma 4. Okay, that is also satisfy the x less than y condition. And then after 5 comma 2 we cannot cover. Okay, we cannot include in the relation because 5 less than 2, that is wrong. Okay, so that we'll ignore. And then after 5 comma 4, that also we cannot consider in this set. Okay, so this is the relations for this condition. Okay, x less than y. Okay, and you just collect this element from this A cross B only. Okay, that should be the subset of the Cartesian product, and now we can consider as the relations which satisfy these conditions x less than y. Clear? So that is the first example for the practice of Cartesian product, how we can define the Cartesian product and how we can consider relations based on this condition. Okay, and if we have only one set, okay, that is one note. If we have only one set, if R is a relation from set A to itself. Okay, set A to itself. Now here B is not given. Okay, we have only one set and we are defined the relations from set A to itself. That is R is the subset of, that is R is subset of A square, means the Cartan product of A with A, that will be the A square, and here it is a A cross A. Okay, and R is the relations on A. So that's R is the relations on A. Clear? That is the relations on A. R is the relations from A, set A to itself. Okay. In this theory, okay, we are considered two different set A and B, and then after we define A cross B, and after consider subset, then it is called relations. But now we consider only one set, and you have to define the relations of the set A to itself. Okay, so how we can define that? If we have only 1, 2, 3, okay, let us take this is a A. One, let us only two entry, 1 and 2. A is equal to 1, 2. So first we'll create A cross A. Okay, so A cross A will be 1, 1, 1, 2, 2, 1. Okay, and 2, 2. This pair you will get in this A cross A. And now consider it a subset R1. So it will be the 1, 1 and 2, 1. Okay, so this R1 relation, okay, this relation is from the set A to itself. Okay, the R is a subset of A square. R is a subset of A square here, and R is a relations on A. Okay, this R1 is relations on A, we can consider. Okay, and if it is a two different set, okay, if it is here A cross B, then we'll consider R1 is the relations from A to B. Right now it is R1 is the relations on the set A itself. Okay, so this is the concept of relations. Is there any doubt, any query in this definitions of relations? Is it clear to all? Okay, good. So next concept is the domain and range. Okay, how we can define domain and the range? It is simple definition that the set as A belongs to A, and the set as AB belongs to R, means the relations. For some B belongs to B, okay, for some B belongs to a B, is called the domain of R. Okay, and it is denoted by domain, okay, DOM of R. Okay, the first entry, the set A belongs to A, for this relations AB belongs to R. The first element, okay, of each the entry, each the pair including this relation, that is called the domain of the R. Okay, the first element. If I include this R as a 1, 1, okay, a 5, 2, and 3, 5. Okay, so this 1, 5, and 3, this first entry of this relation, that is called the domain of this relation. Okay, the first element means A belongs to A, 1, 5, and 3. And after that, definition of range. So the second entry means the B element. Okay, the set B belongs to B. Okay, for the pair AB belongs to R, and for some A belongs to A. Okay, is called the range of the R. Okay, simple definition is there and it's easy to understand. The second entry of the each pair, okay, of the each pair of the given relation, that is called the range of the R. Okay, so it is denoted by RAN, okay, of the R, range of the RAN means the range of the R. So here we consider the domain of the relations. R is the set of first element. Okay, domain of the relations is the set of the first element of the order pair, and the range of this element, okay, range of this uh relations, okay, range of this R, that is the second element of that relations. If we consider one counter example, okay, let us take R1, that is one part of the A cross B, and it is one subset. R is include the pair 1, 5. Okay, right now it is a relations, okay, and it is one subset of the given product set, the given Cartesian product. 1, 5, then after 4, 2, 3 comma 4, okay, and 4 comma 4. This set is given, okay, as a relation. And now you have to identify domain of the R. Okay, domain of the R means the first element of this each order pair. Okay, so it is the 1. Okay, then after 4, 3, and 4. Okay, the first entry, first element of the each order pair, that is the 1. Here it is the 1. Then after 4, 3, and 4. That is called the domain. Okay, and then after range, so range of the R. Okay, otherwise you can consider Rn of the R, and range of the R means the second entry of the each order pair. Second entry is here 5, then after 2, then after 4, and then after 4. Okay, that is called the range of this order pair, range of this relation. Okay, it is simple one. First entry, that is called domain, and second entry, that is called the range. So 1, 4, 3, 4. Okay, the first entry, that is called the domain, and 5, 2, 4, 4, that is called the range. Clear? That is one simple counter example. Now let us take another one. The data is here. Let A is equal to 2, 3, 5. Okay, and B is equal to 2, 4, 6, 10. That is the data. And then check whether the given relations R is a subset of A cross B. Okay, by written them in this order pair. In order pair. First one is here 2R3. Second one is there 2R2. Third one is the 5R6. And the fourth is a 6R5. Okay, we just check, okay, this relations are in this product set or not. Okay, it is a subset or subset of A cross B or not. So here first you can define the A cross B if it is required. Okay, if it is required, then you can then after you can check this pair, it is in subset, it is a part of A cross B or not, means it is a subset of A cross B or not. Okay, so how many entry you can define in this A cross B? Okay, here it is the 3 element are given in this A. Okay, 3 element are in this A, and the 4 element are in the B. So 3 into 4, total 12 order pair you can define in this A cross B. Okay, but we'll check it directly here. Okay, 2R3. Okay, so first is a 2R2. So 2R3. So 2R3 means 2 comma 3. And now check this 2 3 pair will define in the across B or not. 2 means the first entry, means the part of A, and 3 means the element of B. So now check this 3 are not defined in this set of B. 2 4 6 10, this only 4 element are given. There is no such 3 are given in this B. Okay, so we cannot define this 2 3 pair in this A cross B. ओके 2 3 का मतलब क्या है कि जो 2 है वो ए में से आपको डिसाइड करना है, ठीक है, और 3 जो है बी में से डिसाइड होगा, ठीक है, एंड देन आफ्टर कंसीडर इट पेयर एज अ 2,3, but 2,3 pair will not define in this A cross B. Why it is not defined? Because 2 is given in this A, but 3 is not given in this B. Okay, so 2 3 it is not a part of A cross B. Okay, otherwise you can first check the A cross B pair. Okay, all such pair you just covered in this set, and then after you can check that okay, 2 3 are covered or not. Okay, and that will be not covered. So it is answer of first one. Okay, that is the answer of first one. Now second one 2 comma 2. Okay, so 2 comma 2 means 2R2. Okay, 2R2 is given. 2R2 means 2 comma 2 and 2 comma 2 pair. Okay, that will be defined as the first pair in this A cross B, because the first entry is a 2 here, and here first entry is also 2 in the set of B. So 2 comma 2 pair will define in the A cross a B. Okay, so it is the part of the relation. And then after third one, a 5R6. So 5R6 means a 5 comma 6. So 5 comma 6 also will be defined in the A cross B, because the third element is a 5 of the A and 6 is the also the third element in the B. So 5 6 pair, okay, 5 comma 6 pair will be defined in this A cross B. So it is also the part of A cross B. Okay, and then after 6R5, that will be not defined in this A cross B. Okay, because 6 is not related to the 5. 6R5. Okay, so here it is a 6 comma 5, and 6 comma 5 will not be the part of A cross B. Okay, and therefore 6 is not related to the 5. Okay, and here 2 is not related to the 3. Clear? 2 is not related to the 3. Here you can consider. So that is one simple example. Okay, it is the given order pair, it is a subset of A cross B or not. Okay, that you have to check on. And then after second one, the data is there. Okay, let us take A is equal to a 2 3 4. Okay, and B is equal to 3 3 4 5. 3 4 5 is given. Okay, then list of the element of each relation. Okay, and we have to define list of the element of each relations are defined by as follows, and also find domain and range, and also find domain and range. Okay, let's solve it. Domain and range we'll find, and then after here it is given that list of the element. Okay, as per the relation, that is A R B. The condition is that A less than B, and second one A R B. Condition is that A and B are odd numbers. A and B should be the odd number. A and B should be odd numbers. Okay, that we'll consider in this relation. So let us solve the first one. First we'll define the A cross B if it is required. Okay, and then after we can check this both relations. So A cross B, total 9 pair will be defined in this A cross B. Okay, so first pair will be 2 comma 3, then after 2 comma 4 and 2 comma 5. Okay, fix the one element from the set A and make it pair with all element of the B. Okay, so that is first case. Then after second one, change the element 3 comma 3, 3 comma 4 and 3 comma 5. Okay, that is second part. And third part will be 4 comma 3, 4 comma 4 and 4 comma 5. Clear? That is A cross B for the given data. And now the answer of first one, A or B. Okay, we consider such relations to satisfy this condition A less than B. Okay, so now we'll include some pair. Okay, from this A cross B which satisfy the condition A less than B. ठीक है, ऐसी पेयर आपको इंक्लूड करनी है A cross B में से कि जो A less than B condition satisfy करे. A means the first entry and B means the second entry. Okay, so I can consider 2 comma 3 which is satisfy the A less than B condition. Then after 2 comma 4 I can consider, 2 comma 5 I can consider. Okay, 3 comma 3 will not include, 3 comma 4 will include. Okay, because it is A less than B form. 3 comma 5 also will include. Okay, then after 4 3 will not include, 4 comma 4 will not include, and the 4 comma 5 will include. Okay, so this is the relations, okay, which satisfy the condition A less than B. Okay, which include the 6 pair 2 3 2 4 2 5 3 4 3 5 and 4 5. And then after we'll check it domain. Okay, domain for R and the range for R, range of R. So domain is equal to the first entry of the each pair. Okay, so it is the 2. Okay, there is repeated now, so we'll consider only one time. Clear? 2 is repeated 3 times here, so we'll consider only one time. 3 is repeated 2 times here, so we'll consider one time. 2 3 and 4, that is the domain. And then after range, that is equal to 3, and then after 4, okay, and 5 is repeated 3 times, 4 is repeated 2 times, so consider it 1 time, and 3, 4, 5, okay, 3, 4, 5 is the range, and 2, 4, 2, 3, 4, it is the dome. Okay, so it is solution of first one. And now in second one, the A or B, where A and B are odd number. Okay, A or B क्या है, odd number है, so which pair will include in this set? Okay, which pair will include in this set? दोनों odd number होने चाहिए, ठीक है? So we can consider the 3, 3, okay, where both the three, okay, both the A and B are odd number. We cannot consider 2 and 3, 2 and 4, and 2 and 5. Why? Because 2 is the even number is there in this first three pair. Then fourth pair, it is a 3, 3 we can include. Then after 3, 5 we can include, okay, in this relation. Then after 4 is a even number, so we'll ignore this next three pair, okay. So answer of second one, that will be R is equal to, okay, let us write down here. Answer of second one, where A are B, okay, A and B are odd number, okay. So from this pair, from this A cross B, we can consider R as a 3, 3 and 3, 5 only, okay. This two pair we can consider for this relation out of 9, clear? And now the range and the domain. So domain is equal to, domain of R is equal to 3 only, okay, that is the 3, and the range of R, that is equal to 3, 5. Clear? That is the solution of this. Okay, is it clear to all? Is there any query, any doubt? So ask me. Good. And now let us write the third one. There is one empirical form of this example. Let us take S is equal to xy, x comma y. Okay, and you have to create S square. S square be the set of all words of the length 2, of the length 2, and first we'll find the element of S square. The answer is easy, that just there is one empirical form of this example, okay. And then after second one, the relations R on S square, okay, is defined by V and W, means the first letter in V, first letter in V is the same as the first letter in W. It's the same as first letter in W. And V and W are in S square, belongs to S square. Write R as a set of order pair. Write R as a set of order pair. Okay. So answer is very easy, that just some theoretical form of this question is mentioned here. Now let us solve this. So here S is given that it is equal to x comma y. Okay, S is given that, and now you have to create a square. Okay, be the set of all words of the length 2. Be the set of all words of the length 2, means a 2 word only. Okay, if I consider x, y, z, then it is a length of the length of this word is a 3. Okay, if I consider x, y, z, w, then length of this word is a 4. Okay, so here we consider all such words of this s, okay, that should be the length of the 2, okay, length should be a 2, okay, of this each word. So s square will be, that is x comma x, okay, x into x, that one word I can consider, that is the length 2. Then after x y I can consider, okay, then after y x I can consider, that is also length 2, and then after y comma y, okay, that is the word of the s, okay, that is called s square, and it is the word of the length 2. And here it is the solution of first one, find the element of s square. So these are the element of s square, okay. And now in the second question, find the relation on s square is defined by v and w, means the first letter in v, first letter in v is the same as the first letter in w belongs, and v and w belongs to s square, okay, v and w, that should be the part of s square, and we consider the first letter in v is the same as the first letter in w, okay, means we can consider as a r, that is equal to, okay. Now you have to define such pair, okay, define such relations, okay, which will be the part of v cross w, okay, either you can consider s square form, okay, s square is equal to s square cross v s square, otherwise v cross w form, and here we consider it such pair, and which will be our relations and satisfy this condition. First letter in v, first letter in v is the same as the first letter in w, okay. So I can consider x comma x and the x comma y pair, okay. Now check this pair, the first letter of this v, okay, x comma x I can consider from this v, and x y I can consider from this w, clear. And v and w it is a part of s square only. तो ऐसी पेयर आपको डिफाइन करनी है कि जिसका फर्स्ट लेटर, ओके, वो सेम हो, ठीक है. तो x is same here, x comma x, and second is a x comma y, that is the same, clear. Second pair I can consider as a x y, ठीक है, and x comma x, thus interchange this both. So that is the second pair x y and x comma x, clear. X y it is a part of s square, and x comma x it is a part of s square also, and that is v and w form. And then after third I can consider y comma x, clear, y x and y comma y, clear, where first letter is the same. And fourth pair I can consider y comma y and y x, clear. Now this four pair we can define only. Now we cannot create another pair which satisfy this condition, clear. If you consider here x x, okay, and y x, so we cannot consider this pair. Why we cannot consider? Because here first letter is different, okay, first letter is different. Then after we cannot include x y, okay, and the y comma y pair, that is x and y, this first letter is different, okay. So only four pair we can include in such required answer, okay. So that is the solutions of this, clear. And another similar example of this type is that is, just I will write the data only, skip this all theoretical form. S is equal to ABC is given there, okay, ABC is given there, and then we'll find the s cube, okay, be the set of all words of length 3, okay, with the set of all word length 3. And then we'll consider the in this first questions we'll find the relations on S3 R on S3 is defined as a three letter of word are same, so three letter of the word are same, okay, all the three letters of word are the same, okay. That is the condition of first one. In second one, relations defined on first and third letter, okay, the R defined as a first and third letter of the word are same. First or third letter same होना चाहिए, ठीक है, while second letter is different. Okay, while second letter is different, ठीक है, that is the condition and solutions of this one. First का solution क्या आएगा? We have S is equal to ABC is given there, ठीक है. Now we can define S cube. Clear? S cross S cross S. Clear? That way we can define the S cube. S cross S. Okay. N cross S. So that will be 3 into 3 into 3. Okay. 27 pair will be defined in S cube. Clear? 27 pair. But now we would consider the limited form. Means in this first conditions we have given that R on S cube, all the three letters of the word should be same. All the three letters of this word should be the same. Okay. So here it will be S cube. That will be A, and A. Okay. All these three letters are same. Second choice, there is a B, B, and B. Okay. And third will be C, C, and C. So that is the S cube, and we can consider as a R1. Okay. And here all these three letters are same in this. And now there is no in another choice we have where all these three letters will be same. Okay. A, B, C you can consider, A, B, B you can consider, A, S, C you can consider. There is not a same. But in this case only we have all these three letters are the same. And now in second one, we consider R2 as a, okay, let us say it is R1 and let us say it is R2. So R2 is equal to, we just collect all this letter, okay, where first and third letter should be same and second letter should be different. ठीक है, ऐसी पेयर आपको डिफाइन करनी है जहाँ पे फर्स्ट लेटर सेम और सेकंड लेटर डिफरेंट. ठीक है, तो वी कैन कंसिडर ए बी ए. ठीक है, यहाँ पे फर्स्ट और थर्ड सेम है, सेकंड डिफरेंट है. ठीक है, देन आफ्टर वी कैन कंसिडर बी ए बी. ओके, देन सेकंड पॉसिबिलिटी इज सी ए सी and then after ACA, clear, that is the fourth one. Then for B case, BC a B, okay, and CBC, where first and third are same and second letter is different. So this pair you can define from this S cube, okay, where it is a part of the relation and we can consider that as per our condition. Okay, so that is called R2. So is it clear to all? Have you any query, any doubt up to this? Okay, good. And now